Okay, Assalamualaikum and good afternoon. Today we are going to do our last module, module 13, Wlan configuration. Last week we have taken a look what Wlan concept, how to set up or how to build up a wireless network, and what technology that we have, several increment in the technology starting from 802.11 up to now 802.8x and ACAS and so on. So now we are going to take a look how to configure. Even though you already do some of the exercise, I'm already do a demo how to do. But today I'm going to explain, but not in briefly. Okay, in this module there are several topics. Okay, the objective of the module actually to implement a WLAN using a wireless router and wireless LAN controller. Okay, our first topic is the remote site WLAN configuration. How to configure or how to enable WLAN to support a remote site, which means sometimes we already cover our network. Okay, we already have our wireless LAN network in our office, but they are extension of our office that our current wireless doesn't cover that. So in order to extend them, so we call as a remote site. How to configure a NAP. Okay, after that, configure a basic WLAN on the WLC. So after that, we are going to do or to enable WLAN configuration inside our wireless LAN controller. We have done all this exercise. And the next actually configure a WPA2 enterprise WLAN on WLC. Okay, we also have do this experiment. Okay, instead of using a share key, which means we are using the same password for everybody, we can set up an enterprise authentication, which means we are able to create a username for everybody, even though there is no in our scope to create a username and password, but we already have a server created in our packet tracer activity. We need to configure our WLAN controller in order to use that. So in this topic, we are going to do several activity or several experiment, such as to create a VLAN interface to be used with a wireless LAN, to enable or set up the HTTP server, to enable SNMP even though it doesn't state it here, and lastly to do WPA2 enterprise authentication. And our last topic actually troubleshoot or WLAN issue. Okay, let's go to our first topic, 13.1, remote site WLAN configuration. Okay, if you go to our NetAcad, you should see there is the first topic, first video. Okay, first topic in our NetAcad, actually 13.1.1, there is a video explaining everything in order to set up a wireless router. Okay, to change the password, to change WAN and LAN setting, and to connect to wireless network. This is the video how to do with a real device. Even though you cannot go to our lab to use the see a real device, you can use the video as a comparison with we have done during our packet tracer activity. It's almost the same actually. I'm not going to play this video. It's gonna take 9 minutes. I hope you can view by your own after this. But there is some explanation what we have. So in that video also. So for the wireless router, actually is a device that include a switch for a wired client and a port for internet connection, which means there is a WAN port in order to connect to broadband modem and to the internet or to the ISP, and we have the switch port for you to connect directly through a wire and a access point, a wireless component. Okay. Other than that, it also provides some configuration or some what we call capability. So you can do a WLAN security in here to change the password, set up password. DHCP service also include inside our wireless router. Integrated name address translation or NAT. You can do NAT inside our wireless router. Of course, they do NAT. When you connect to the internet, you are creating a local network with a private IP. So in order to connect to the internet, you need to have a NAT. And lastly, quality of service. But there is our scope is not to touch for everything. You should know this. But in order to configure all of this, actually very easy. You can do by your own. If you have some device, you can play around. Okay. Okay, to log in. In order to log in, you need to know the default IP address. Usually, it came with a user manual, or you can search from the internet. You default username and password. With that, you can connect through the web browser from another terminal, another PC that directly connected to that wireless router through a wired cable and so on. Okay, so in order to set up all this, you need to log in, change the default administrative password. That's what I do when I do the exercise. Even though our packet trace activity, they do this in the last step, but never mind. You should change the default password and then log in with a new administrative password. Change the default DHCP IPv4 address. But for our activity, we try to use the default one first. When we finish with that, then we can conclude that our configuration is good. Then we change to a new DHCP IP address, and then we renew our IP on our PC and log into a new IP address. So for basic network setup, and then for basic wireless setup, the same thing. Okay, they may be provided a default SSID, so we should change them. But before that, you should select which standard that you would like to implement. It all goes back to the client. What standard that client support. If you have a newer device, you should select the newer standard inside your wireless router. Configure the channel. Sometimes you can pick the auto, but you must ensure there is no overlapping. Configure the security mode, either WPA, WPA2 personal or WPA2 enterprise. And if you select for any security mode, you need to pick a password or username and password and so on. And sometimes, like I said earlier, to cover a remote site that doesn't cover with the current wireless router, so we extend by including a new access point. We have done this inside our packet tracer activity, so I'm not going to explain detail on that. Okay, this is the interface in our wireless router. So there is a service. There are so many services in there. I do not go through everything, but for here we are going to explain what is a NAT. NAT is a network address translation. In order to translate your private IP into a public IP or into another private IP that you have, which is routable to the network. Maybe sometimes you are inside some organization. They have their own public IP, let's say 10 something, but it doesn't route network 192.168 something. But you create that network inside your AP. So for any device that using IP address 192.168 something, in order to go to the network 10 something, which is routable inside the organization, they need to have a translation. So NAT will do all of that. So you will learn about NAT later in the next semester or next CCNA class that you took later. Okay, quality of service. In order to prioritize what traffic should go or should have a higher priority and so on and so on. Okay, we are not going to do everything. Okay, port forwarding. There is another service inside your wireless router. Sometimes your client, you need to have a direct connection between the internet, so you can do a port forwarding. Of course, your wireless router doesn't provide a connection for your device. Let's say in your home, for your unified connection, I would like to use the example of our broadband that we have. Unified or Maxi, you have a public IP within that Maxis or unified network, but in your home, you using a private IP. So all the connection, TCP and UDP port for your client are not forwarded by the router. Of course, you cannot connect directly because internet are using a public IP. So internet are able to connect up to the wireless router. So how the wireless router are going to connect to your device when they ask for connection? So we need to enable port forwarding. Let's say you enable a web server on your PC inside internal wireless network. So you can enable port 80, but remember, your wireless router already used the port 80, so you must use another port. Okay. So to forward to your port inside the client, that's a port forwarding. Okay, so there is an experiment 13.1.10. We have done this to configure a wireless router, and then to extend through AP, and lastly to change the IP address, and then everybody should be able to connect. We also have a lab exercise which is using a physical devices 13.1.11, but we are not going to do this. So you can view the data from our NetAcad how to do that, but you cannot do that. But if you have the device, you can do by your own. Okay, that's all for 13.1. Now we go for 13.2. Configure a basic WLAN on VLAN, on wireless LAN controller. Okay, starting with this topic, we have a video introduction. There is a very good explanation in order to do the exercise, packet tracer exercise. I think you should review back this video. Okay, they explain everything what you have done by using a packet tracer activity before. So you can reflect back what you have done before. So review the topology, how to access the UI through a PCB, and so on. Okay. So this is the topology as I explained to you during our exercise, our lab activity. There are two networks on router 1. I mean, two networks connected to the switch 1. They are not following the same IP address scheme, but the experiment actually almost the same like this. But they are using the different set of IP address only. Okay. Okay, after that, to log in to WLAN controller, you just put the IP address, but remember we must use HTTPS, not HTTP. Okay, we have done this during our 13.2.10 experiment wireless, packet tracer activity. There's a lot that can view. If you are using a real device, you can view the info regarding your access point. But remember, when we do our packet tracer, if you click our AP, there is nothing that we show. So this is what actually we show when you click for the AP1 that listed inside our access point. Okay, so this is the interface that you should see when you do during a packet tracer. But this is a real interface actually. So to configure a wireless local area network, you need to create wireless local area network, which is you need also to have a specific VLAN, which is we create later, apply that, and then you follow all those things, you should be able to do that. We have done this, so I'm not going to explain everything. So you can follow or you can check by your own after this. To create the network and then enable, after you click the apply, you should pop up this page or this page. And then you should enable, and then you must configure security and advanced. Okay, all of this here. Okay, security, enable password, you must select WPA2 and then create the user password. Okay, so sorry, 13.2.7, not 13.2.10. Okay, so this is the experiment that we do in our packet tracer activity. So I'm not going to explain that more. So after that, we have the 13.3, configure WPA2 enterprise wireless LAN on the wireless LAN controller. So we also have done the exercise in this topic, but you can view the explanation through the video, the first topic inside the first learning module inside this topic, 13.3.1. So they explain everything, how to enable SNMP, simple network management protocol, and radio server. Radio server actually for creating a username and password. So if we are using a real device, we are using the PC as a server. We can enable a SNMP server and a radio server, remote authentication die-in user service. Radio server actually for AAA service, authentication, authorization, and accounting. So if we have a radio server in our server or any device, so you can connect to the network and enable it inside our wireless LAN controller by providing the IP address of the radio server. And then for all the network, for the security, you are not selecting the WPA personal, but you select WPA2 enterprise and then provide the radio server. So that's all how to enable it. Okay, for the SNMP, actually SNMP for simple network management. Actually, for a management, you have a server to monitor all the device. So what the device do when you enable SNMP, they will send a log message for a for a period of time. Let's say you should log for every 10 minutes, for every 10 seconds, I don't know. So if you do network management, you should do this. So they will send a log, indicate their status and so on. So inside the SNMP, they can provide the statistic and info regarding any device, what happened now and then. Okay, this is how to enable a radio server. I'm not going to explain then. And then lastly, enable. Okay, we have a video 13.3.5 to create to configure WPA2. But before that, we are creating a VLAN. We need to create a new VLAN for our wireless local area network. Sometimes we are using the same VLAN as our wired. Sometimes we are using a new VLAN. It doesn't matter. So if you need to create them. So this is what happened. So you can see here for Ethernet, Fastnet 0/1 on router 1, we have multiple IP address. So you have 192.168.200 something and 192.168.5 something. 5 something is a new VLAN that we are going to create for our wireless. But that wireless IP also connected to the router. So they have a multiple VLAN. So a wireless user, we use a different VLAN. So this is how to create a new interface, for a new VLAN. So you can follow the step here, but we have done this in our exercise. Then when we have our VLAN, we can mesh it with the WLAN wireless local area network. Okay. There is also another videos configuring a DHCP code, but it's very easy actually. Even though you do not go to the video, you can enable it easily. Okay, through this page. Okay. And lastly, when we already have everything, we can enable WPA2 Enterprise. So you have a packet tracer activity 13.3.12, which is we already done that. Even though I do not do a demo, but I've already show you how to follow all the steps in order to that. So this is all the thing that we going to do in order to enable WPA2. Actually, WLAN is not necessary for WPA2, but for all other network. Even though you are using WPA, personal and so on, you need to do this. But from previous experiment, we just use what already been configured for us. But in this experiment, they show you how to create them. But the new thing actually, to enable SNMP and radio server. When we have a radio server, we can use with the WPA2 Enterprise. So that's all for our 13.3. So lastly, for our troubleshooting WLAN issue, there are several activities here. But for a wireless local area network, it can be simple or complex. Result from the combination of hardware, software, and the connectivity issue that you have. So in order to troubleshoot, you have to take a look very carefully where you want to fix them. Okay, you should be able to identify the problem, where it comes. So in order to do that, so how to identify the problem? Maybe you should interview the user, what happened and so on. After that, you establish a theory of probable cause. You should have some idea where you should start. Test the theory. Based on the probable cause, test the theory to determine which one of the cause of the problem. We apply the quick procedure to see if this problem is solved or not. If not, we might go to the next research. Okay. Establish a plan, action. Verify full system functionality, and then document. Why we need to document? Because later, if we have the similar problem, we can refer to the document what we have done, how to overcome that, and so on. So some of them, wireless client not connecting. We can view from the PC itself or from the client. Even the Windows operating system, you can do ipconfig to view Does it get the IP address or not? Sometimes it doesn't get the IP that we created through the DHCP. It get the IP what we call IP path standard. So which means there is no DHCP connected or achievable by that PC. So you need to fix that or try to load something. Is the PC in the coverage area? Sometimes you doesn't get the signal. Check the channel of the wireless setting. Is it the same with your PC? I mean, does your device support that? Check the interference with the 2.4 GHz band. Okay, most of the time 2.4 GHz have a interference when they use the same channel. So if the same channel, the quality will be lower, so the client might not get anything. So consider a physical issue also. Is the power already done? Or I mean, you have power on everything and so on. So you should check them. Okay, if you have done everything but there is no fix, maybe you need to upgrade your wireless client. You are using a very old standard which doesn't support anymore. So although 802, the 11B, 11G, even 11N also is considered slower today. Okay, most of the current device should use AC or AX and so on. Okay, split the traffic. If you have a router that enable or have a multiple broadband, I mean they can use a multiple wireless broadband, I mean 2.4 GHz and 5 GHz, we can split them and then we can have two separate network. So you should be able to not downgrade, to increase the bandwidth of the user by split into multiple network. So there is a note here. The 2.4 GHz band may be suitable for basic internet that is not real-time sensitive. Remember, 2.4 GHz, they can achieve a longer distance, but they cannot carry very high density of data compared to 5 GHz. But the bandwidth may still be shared with other new LAN, WLAN. Okay, remember, even though the speed is 300 megabit per second, so they are shared by all other devices. Okay, 5 GHz band is much less crowded than 2.4 GHz band. Ideal for streaming multimedia because it have a high bandwidth, but it doesn't less crowded because it doesn't. They have a shorter range compared to 2.4 GHz. Okay, and 5 GHz has more channel, so likely no interference. You can select a different channel compared to 2.4. They only have a 11 channel, but usable at one time actually a 3 channel only. So you are only allowed to have 3 AP at one time. I mean at the same place. If you have multiple, then there is a chance for interference. And of course there is an interference if you do in your home network. You have a neighbor nearby which is in the same coverage with your AP and so on. But luckily you are nearer to your device, so you should have a very good quality compared to when you are at the edge of the coverage. Okay, by default dual band router we use both and use the same name. So the user will select automatically, but you can choose a different name and so on in order to segmentation the traffic. So sometimes you need to update the firmware. You are using the very old firmware, then there is increment in order to increase the speed in the standard, but doesn't need to use the new hardware. We just need to upgrade the home firmware, then we can upgrade the firmware. So this is how to upgrade the firmware. And there is a packet tracer activity, troubleshoot WLAN issue. We are going to do this week. Okay, so that's all for our module 13, but there is some exercise I want you to do. Okay, in our NetAcad for practice and summary, there is another packet tracer activity, and that's WLAN configuration, how to configure and so on. Actually, just some advanced, not advanced, actually some what we call challenge network compared to the previous we call as a simple network. Okay, wireless in the physical mode, we can do that after this. Okay, so That's all with the WLAN configuration. I think there is not much on the theory because we already cover in the WLAN concept. So that's all. Thank you.